You know that feeling when you're trying to keep up with something like blockchain? It moves so fast.
Oh, absolutely.
It's just this constant flood of information, new stuff every week, it feels like. And you want to get what's important, the real breakthroughs, but without feeling like you need another degree just to follow along.
Exactly. You're trying to find the signal in all that noise.
Yeah.
And, well, that's precisely why we're doing this. This is your custom deep dive. We take something complex, something important, and boil it down to the essentials.
Like an express lane to understanding.
Pretty much. So you actually get what matters and why it matters.
Okay, so today we're zoning in on a really key document, the Chainlink 2.0 white paper.
Hmm.
We're not aiming to, get totally lost in the weeds, technically speaking. The mission is to pull out the core ideas, maybe some surprising bits, the really crucial insights. So you walk away feeling like genuinely informed, maybe even a bit ahead of the curve, but definitely not overwhelmed.
Information overload, that's the plan. And this white paper, it's worth noting, comes from Chainlink Labs, but also folks from top universities, UC San Diego, Illinois, Harvard, Stanford. So serious brain power behind it.
Right.
And it lays out this pretty ambitious vision for decentralized Oracle networks, DONs, how they're evolving beyond just, feeding data onto the blockchain.
Okay. So our mission, get under the hood of Chainlink 2.0. What's really new compared to their first white paper? What are the big design goals? And what could these dawns actually mean for the whole blockchain world?
Sounds good.
All right, let's unpack this then. What's the big picture? The main vision driving Chainlink 2.0?
So the core idea is Chainlink moving beyond just being a data pipeline. They're aiming to become this universal connectivity and computation layer,
Okay.
specifically for what they call hybrid smart contracts.
Hybrid smart contracts.
Yeah.
Okay, that sounds like a term we need to break down. What are they? What's the hybrid part?
Right. So basically, they're smart contracts that blend on-chain logic with off-chain components. See, purely on-chain contracts, while they're the foundation, they have limits, right?
Sure. Speed, cost.
Exactly.
Yeah.
They can be slow, expensive, and they're kind of isolated. They can't easily grab real-world data or do really heavy computations that you wouldn't want to run on the blockchain itself.
Okay, so that's where oracles traditionally come in bridging that gap, bringing external data like prices onto the chain.
Precisely. But Chainlink 2.0 sees this going way further than just price feeds. Their long-term goal is this thing called a decentralized metalayer.
A decentralized metal layer.
Yeah, it sounds a bit abstract, I know. But imagine a future where developers, when they build an application, they don't have to constantly worry, okay, does this bit run on-chain or off-chain? That distinction sort of fades into the background.
Okay. Can you give an analogy? Make it a bit clearer.
Sure. Think about programming for a computer today. You got your main processor, the CPU,
Yeah.
maybe a graphics card, a GPU.
Yeah.
Right? As a developer, you mostly write your code at a higher level. You don't usually micromanage exactly which instruction runs on the CPU versus the GPU. The compiler figures that out.
Right, it optimizes it.
Exactly.
Yeah.
So the decentralized metalayer is aiming for something similar. A developer can just define what their dApp needs to do, functionally speaking. And this metalayer, maybe through some kind of decentralized metalayer compiler, would figure out how to best execute that across different blockchains, DONs, maybe even traditional systems. It's about abstracting away the complexity. So you don't need to be a deep blockchain expert for every single piece of your application.
So it's kind of like a universal translator for dApps, making it easier to build these complex things that talk to both the blockchain and the outside world.
That's a really good way of putting it, yeah. And they even have a name for apps built on this.
Meta contracts.
Meta contracts.
Yeah, these would just combine the on-chain and off-chain parts seamlessly. Now, look, this is a big, long-term vision. It needs advances in languages, security, lots of coordination.
Sure, it's ambitious, but it gives you a sense of where they're aiming, the ultimate potential.
Okay, so hybrid smart contracts are the path towards this meta layer. And the engines powering them are these decentralized Oracle networks, the DONs. Can you define what a DON is fundamentally?
So a DON is essentially a committee, right? A group of independent Oracle nodes. They work together to give smart contracts abilities that blockchains just don't have natively.
Like what?
Things like networking, connecting to external APIs, data sources, secure off-chain storage, and importantly, performing computations off-chain that might be too expensive or complex for the blockchain itself.
So it's definitely moved beyond just fetching data. It's about adding off-chain capabilities.
Absolutely. And a really key point is they're designed to be blockchain agnostic. Meaning a DON isn't tied to one specific blockchain. It can serve smart contracts on Well, potentially any supported main chain. It's meant to be a flexible tool for developers everywhere.
That's power.
Yeah. And the white paper lays out 7 key design goals driving these 2.0 advancements. We've touched on enabling hybrid contracts and abstracting complexity, but also scaling, confidentiality, fair transaction ordering, minimizing trust assumptions, and using cryptoeconomics for security.
7 goals. Okay, that's a lot. Let's maybe dig into some of the specific services these DAWNs enable. The paper mentions proof of reserves. How can a DAWN make that better for something like, say, wrapped Bitcoin?
Right. Proof of reserves is crucial for assets like WBTC on Ethereum, which needs to be backed one-to-one by actual Bitcoin. Often, one custodian holds the keys and the responsibility.
Which is a central point of failure.
Exactly. A DAWN can improve this by acting as a sort of decentralized custodian, or at least a network of verifiers. Because it's multiple independent nodes, it can manage the keys needed to interact with the original Bitcoin blockchain in a more distributed, secure way. It can also continuously monitor the Bitcoin deposits and withdrawals and report that transparently to the WBTC contract on Ethereum. So you get much stronger, verifiable proof that the wrapped tokens are actually backed. More eyes, basically, but decentralized.
That makes sense. Distributed trust, better transparency. Okay, another area, interfacing with enterprise systems. This always feels like a big hurdle for blockchain adoption. What are the main challenges enterprises face, and how do DAWNs help?
Yeah, you really hit on a key point there. Enterprises struggle with a few things. One is just the pace of change.
Yeah.
The white paper calls it blockchain agility. Hard to keep up.
Right.
They might not have the internal experts. Managing private keys is a whole new world of risk and complexity for them. And of course, they're very careful about putting sensitive business data onto public chains.
Understandably. So how do DAWNs bridge that gap?
They can act as this blockchain agnostic middleware layer. A single DAWN can talk to multiple blockchains and integrate with existing enterprise IT systems via secure APIs.
Simplifying things.
Hugely. Developers can build applications without needing to be experts on every single blockchain their partners might use. And critically, DAWNs can provide proof attestations about what's happening in an enterprise system without revealing the sensitive data itself. They mention using things like Deco and Towncrier for this privacy-preserving verification.
Okay, that privacy aspect seems massive. Verifiable proof without data exposure. That could really lower the barrier for businesses. Let's shift to decentralized identity. Lots of promise there, but it seems like current systems have limitations. What are they, and how can DAWNs help?
Yeah, the idea of users controlling their own digital identity is powerful. But current approaches often stumble. They don't always play nice with the existing web systems everyone uses.
Right, compatibility issues.
Exactly. And key management handling your private keys can be way too complicated for regular users. Plus, preventing Sybil attacks where one person pretends to be many without killing privacy is a tough nut to crack.
Definitely heard those complaints. So what's the DAWN solution?
DAWNs can potentially help on several fronts. For compatibility, things like Deco allow DAWNs to verify info from existing web services using current logins without forcing those services to change everything.
So leveraging what's already there.
Right. For key management, maybe DAWNs could enable more secure distributed storage, perhaps using secret sharing, with easier recovery options, maybe linked to existing web accounts you trust. And crucially, DAWNs can enable privacy-preserving ways to prove things like you're not a Sybil account, or even your creditworthiness, without just blasting your personal data everywhere.
Can you give some concrete examples? Like, how would this look in practice?
Okay, think about KYC, know your customer. Instead of uploading your passport to every single crypto exchange,
Oh.
imagine having a verifiable ID credential managed with the DAWN's help that you just present. Much smoother, much safer than having your data copied everywhere.
It's definitely better.
Or think about DeFi lending. Right now, it's mostly over-collateralized. You need to put up more than you borrow. DAWNs could enable sharing verifiable credit history privately. This could unlock under-collateralized loans, making DeFi accessible to way more people because lenders could actually assess risk without seeing your whole financial life. The paper also mentions verifying investor accreditation privately too.
Wow. Under-collateralized loans in DeFi. That would be a game changer. Okay, moving on. Confidentiality preserving DeFi and these things called mixicles. Sounds interesting, like mixing things up.
Small laugh. Yeah, that's kind of the idea. Mysticals are a technique to add confidentiality to DeFi. The white paper uses a binary option example.
Yeah.
Alice bets Bob that, say, Carol's bubble token price will be above X at time Y.
Okay.
Normally in DeFi, the Oracle reports the price to the contract. Everyone sees the price. Everyone knows who won and based on what. No privacy.
Right. Transparency cuts both ways.
Exactly. So a basic Mexico uses a Don. The Don takes the price feed, runs some simple logic off-chain, basically. Was the price above X or not? And instead of reporting the price, it just reports a binary switch value, yes or no.
Huh, just the outcome.
Just the outcome needed for the contract to pay out correctly. The actual price, the specifics of the bet, stay hidden from observers on-chain.
Clever. Privacy preserved, but the contract still works.
Precisely. And you can potentially make it even more private. Using Deco or Town Crier, maybe the Don doesn't even need to know the underlying asset or the bet details itself. Just executes the logic blind, essentially.
That's pretty strong privacy.
Imagine billions in options trading happening privately in DeFi. That's the kind of potential Mixicals point towards.
Okay, huge implications for DeFi privacy. Let's switch gears to scaling solutions and fair transaction sequencing. We all know blockchains can get slow and expensive. How do Dons help with scaling? And what's this fair sequencing thing about?
Right, scaling is critical. Dons can help through something called the Don Transaction Execution Framework, or DONTEF. Think of layer 2s as adding faster lanes to the main blockchain highway.
Yeah, like roll-ups.
Yes, exactly. DONTEF allows Dons to process updates for main chain contracts much faster and cheaper off-chain. They mentioned supporting techniques like roll-ups, optimistic roll-ups, Validium, these different ways of batching transactions off-chain, and then posting proof of results back to the main chain.
So the heavy lifting happens in the Don, keeping the main chain less congested and cheaper.
That's the core idea. TEF offers potentially higher speed, lower fees, and you can even get the confidentiality benefits of Dons in this layer 2 environment. There are trade-offs, of course, like maybe slower withdrawals back to the main chain, or complexity is making things work seamlessly across different Dons.
Got it. And fair sequencing services, FSS, sounds like it tackles front-running.
It does. Front-running, where someone sees your transaction waiting and jumps the queue with a higher fee to profit from it. It's a big problem. Costs users millions.
Yeah, MEV.
Exactly. Minor extractable value or maximal extractable value now. FSS aims to decentralize how transactions get ordered. Instead of going straight to miners or validators who might reorder them, transactions could go to a Don first. The Don then orders them based on a fair policy, ideally. First come, first served based on when the Don received it, and then submits the ordered batch to the blockchain.
So the Don acts like a neutral ordering layer, preventing miners from messing with the queue.
That's the goal.
Yeah.
Create a more level playing field. The paper talks about different ways to do it, contracts that only accept Don-ordered transactions or ones that prioritize them. They also mention crypto techniques like threshold encryption to hide transaction content until it's ordered, making front-running even harder. The aim is order fairness.
Makes sense. Leads to a more trustworthy system. Okay, final big area, trust minimization. If we're relying on these off-chain Dons, how do we make sure we don't just have to blindly trust them?
Good question. Trust minimization is key. The goal is Dons that are inherently trustworthy because they're decentralized, use crypto proofs, and have economic incentives, which we'll get to. Users can even pick Dons or build their own with nodes they trust. But beyond that, the white paper lists several mechanisms main chain contracts can use to double-check or add layers of security on top of the Dons and even the data sources.
Like what kind of mechanisms?
Okay, so there's data source authentication. Data providers digitally sign their data, so you know it hasn't been tampered with since it left the source. They mention things like OpenID Connect or signed HTTP exchanges as stronger than just basic web security, though you still need the Don for reliable delivery.
Okay, signed data. What else?
Don minority reports. If a small group of nodes in a Don sees the majority doing something wrong, they can raise a flag.
Ah, an internal check.
Yeah. Then guardrails logic built into the smart contract on-chain that watches for weird data or behavior and can pause things. Failover clients, alternative software nodes can switch to if the main one has a bug. Circuit breakers, automatic pauses based on conditions like data varying wildly, or if a minority report comes in.
Lots of safety nets.
Right. And escape hatches, sort of emergency brakes that trustees or the community can pull in really bad situations. For the T-scaling stuff, they also talk about having backup on-chain ways to execute things or relying on the signed data source if the Don fails. Combining signed data with minority reports seems like a particularly strong combo for security.
It definitely sounds like a multi-layered defense. Very comprehensive. Okay, you mentioned economic incentives. That brings us neatly to the last piece. Incentive-based cryptoeconomic security. How do you actually make sure nodes want to be honest?
This is where crypto meets economics, right? You align incentives, make it profitable to be good, costly to be bad.
Okay.
Two main types. First, staking. That's explicit. Nodes lock up LNK tokens as collateral. If they misbehave, lie, go offline, they get slashed, they lose some or all of that stake.
Skin in the game.
Exactly. And they talk about aiming for superlinear staking impact. The idea is making the cost to bribe the network grow way faster than just the total value staked. So attacking becomes economically irrational, ideally quadratically more expensive.
So the more value staked, the exponentially harder it is to corrupt the network.
That's the ambition. The second incentive is implicit. Future fee opportunity, or FFO.
Okay.
Basically, reputation matters. Good, reliable nodes attract more business, earn more fees over time. If you mess up, you damage your rep, lose future income. So there's a long-term incentive to play fair.
Ah, the long game.
Yeah, they describe it as a virtuous cycle. More users means more activity, means more fees for honest nodes, which makes being honest even more attractive, which brings in more users because the network is reliable.
A self-reinforcing loop. Nice.
They also mentioned how staking might work, with nodes acting as watchdogs, flagging bad reports. Successful watchdogs get rewards from the slashed stakes of the bad actors. False flags get penalized. Concentrating rewards for catching liars makes bribing much more expensive for an attacker. And they even float the idea of misreporting insurance users getting compensated if an Oracle report is proven wrong and causes losses.
Wow, okay. That was a really thorough tour of Chainlink 2.0. So just to recap the big takeaways, we're seeing Chainlink aim way beyond just data feeds. It's about enabling these complex hybrid smart contracts powered by versatile DONs.
Right.
And these DONs are designed to tackle major challenges like confidentiality, fair ordering, scaling, enterprise integration, all underpinned by layers of trust minimization and strong economic incentives.
Precisely. And it all comes back to building a more functional, secure, and ultimately more useful decentralized web. Addressing that initial feeling you mentioned, trying to make sense of it all. Hopefully there were a few aha moments in there.
Definitely. Thinking about private DeFi or under-collateralized lending, those are pretty big ahas.
Yeah, they have significant potential.
Absolutely. It's still a lot to digest, but it paints a really interesting picture of where things could go. So here's a final thought, maybe. As Chainlink pushes towards this decentralized metalayer vision, how might our whole idea of on-chain versus off-chain start to blur? And what completely new things might become possible then for the internet, for digital agreements?
That is a great question to ponder. Really gets at the heart of the potential transformation. And, if any of this sparked your interest, digging into the white paper itself or researching specific things like layer 2s or decentralized identity is definitely worthwhile. There's a lot more detail there.
For sure. A fascinating space to keep watching.